Hello everyone, myself Akshita from Sri Venkateshwara College of Engineering. Today I am here to explain the topic about interprocess communication. Let's move into contents. Interprocess communication in Linux, types of interprocess communication, signals interprocess communication, dbus interprocess communication, uses of dbus, features of dbus and conclusion. Let's move into interprocess communication in Linux. IPC, that is interprocess communication in Linux, refers to the mechanisms and techniques that allow processes to exchange information, share resources, and communicate with one another. This involves synchronizing their actions and managing shared data. Interprocess communication in Linux allows processes that are running on the same system to communicate, coordinate, and exchange data. Consider the following scenario. You have a client-server application. The client and server are independent processes that operate on the same Linux system. The client makes requests to the server, which processes the requests and returns responses to the client. This communication can be established via interprocess communication mechanisms. Types of interprocess communication. The Linux kernel has many interprocess communication mechanisms that allow processes to communicate and collaborate. Processes can exchange information and synchronize their actions by using the interprocess communication mechanisms provided by the Linux kernel, enabling efficient and cooperative system operation. Here are some of Linux interprocess communication mechanisms. Signals. A signal is a notice to a process that an event has occurred. They are a lightweight form of interprocess communication that can be sent between processes to handle events like process termination or user-defined events. Anonymous pipes. In Linux, anonymous pipes are a type of interprocess communication mechanism that allows connected processes to communicate with one another. They offer a one-way data transmission route between processes. The pipe is created by the parent process using the pipe system call, and it is accessible to both the parent and child process after forking. The parent process writes data to the pipe's write end, while the child process reads from the read end. FIFO. FIFO is a Linux interprocess communication mechanism that allows unrelated processes to communicate with one another. It uses a unique name file as a channel for data exchange. FIFOs can be created using commands like mkfifo or programmatically with mkfifo system call. SysV message queues. SysV message queues is a Linux interprocess communication mechanism that enable process to exchange messages via a message queue. The system V message queue is designed for server applications. POSIX message queue. The abbreviation POSIX stands for Portable Operating System Interface. POSIX message queues are an interprocess communication mechanism that has been provided in Linux since version 2.66 May 2004. It allows processes to exchange data in the form of messages to complete their tasks. SysV shared memory. SysV shared memory enables sharing of memory resources across multiple processes. It allows for the rapid and efficient exchange of massive volumes of data between processes. POSIX shared memory. POSIX shared memory is similar to SysV shared memory but corresponds to the POSIX standard. It provides a more adaptable and portable interface for sharing memory between processes. SysV semaphores. SysV semaphores are used for process synchronization and mutual exclusion. They enable processes to coordinate access to shared resources by using atomic operations such as wait and signal. POSIX semaphores. POSIX semaphores serve the same purpose as system-V semaphores, but POSIX semaphore calls are significantly simpler. Then SysV semaphore calls. POSIX semaphores have been available on glib-based Linux systems since version 2.6. Futex locks. Futex, fast user space mutex. Locks are a lightweight process synchronization mechanism. The fundamental goal is to provide a more efficient mechanism for user space code to synchronize multiple threads with minimal kernel interaction. Memory mapped. File backed and anonymous shared memory using memory map. Memory mapped interprocess communication enables process to exchange memory regions mapped to the same file or anonymous memory. It provides a high performance mechanism for transferring data across process. Unix domain sockets. Unix domain sockets are similar to network sockets but are used for communication between processes on the same mission. Unix domain sockets support both stream-oriented TCP and datagram-oriented UDP protocols. Netlink sockets. Netlink sockets is a Linux kernel socket interface that allows inter-process communication between the user space and the kernel, as well as between multiple user space processes. Network sockets. Network sockets enable processes to communicate with one another via a network. They provide a common interface for inter-process communication between missions. D-bus subsystem. D-bus is a mechanism of inter-process communication between processes in Linux and other Unix-like systems. It has a layered structure. D-bus was particularly designed to fulfill the needs of current Linux systems. It provides a message bus architecture and supports various programming languages and platforms. Let's move into Signals interprocess communication system. Signals in Linux allow processes to communicate with one another by sending notifications or triggering specific actions. Consider signals to be messages that process can send to one another. For example, when a user hits Ctrl+Z, the keyboard generates an interrupt. The operating system then sends a SIGINT signal to the running process. When a signal is received, the process temporarily suspends its usual execution and executes a distinct block of code known as the signal handler. In Linux, all signals have a default set of signal handlers, reducing the need to handle them individually for each program. As a result, signals provide a mechanism for process to respond to system events or interruptions, allowing for effective communication and control. Let's move into dbus inter-process communication. Dbus is a mechanism of inter-process communication between processes in Linux and other Unix-like systems. It has a layered structure. Dbus was particularly designed to fulfill the needs of current Linux systems. Its major goal was to replace current remote object systems in GNOME and KDE, such as Corba and DCOP. The goal was to build dbus as a universal and neutral inter-process communication mechanism that could be used by both desktop environments, responding to their requirements while bringing new features. Dbus was created to be a complete IPC solution combining GNOME and KDE communication capabilities and paving the way for enhanced functionality and interoperability. Uses of dbus. Let's look into uses of dbus. Dbus is a full-featured inter-process communication in Linux, an object system that can be used for a variety of tasks. Firstly, it supports essential inter-process communication IPC, which allows process to communicate data like Unix domain sockets but with enhanced features. Secondly, dbus enables the transfer of events or signals across the system. facilitating enhanced communication and integration between various components. Finally, dbus provides a remote object system which allows an applications to request services and call methods from a different objects. This feature is similar to Corba but with less complication. Let's look into features of dbus. Dbus stands out from other inter-process communication mechanisms in a few key ways. Firstly, it operates on discrete messages rather than byte streams. Each dbus message is made up of metadata headers and data payload, resulting in a well-structured binary format. This is in contrast to other inter-process communication mechanisms in which communication is based on arbitrary streams of bytes with no specified message format. Secondly, dbus uses a bus-based system, while direct process-to-process communication is feasible. Dbus includes a message bus daemon that acts as a central hub for routing messages between processes on a certain bus. This results in the formation of a bus topology in which process can communicate with one or more applications at the same time. Finally, dbus is distinguished by the existence of two types of buses, system buses and session buses. The system bus is global and covers the whole system, allowing communication between all authorized users. It makes system-wide events and interactions possible. The session between the other hand is created during a user's login session and it's unique to that user. It works for the user level, allowing inter-process communication in Linux and remote object system functionality to be adapted to the user's applications. Conclusion. A process is the fundamental unit of execution. When a high-level programming language program is compiled, an executable file is created, which can be considered a process. Inter-process communication in Linux refers to the mechanisms and techniques that allow processes to exchange information, share resources, and communicate with one another. Inter-process communication in Linux allows processes that are running on the same system to communicate, coordinate, and exchange data. Signals in Linux allow processes to communicate with one another by sending notifications or triggering specific actions. When a signal is received, the process temporarily suspends its usual execution and executes a distant block of code known as the signal handler. Dbus is a full-featured inter-process communication mechanism which allows processes to communicate data like Unix domain sockets but with enhanced features. Thank you.